Hello viewers, good day. This is Turning Point Tutorials. We appreciate that you've come for another lectures today. We are looking at a very important lesson before us. If you check the board, we already have trigonometry as a topic. So today we'll be dealing with the topic trigonometry. Question 9 is, what is trigonometry? You know, seeing this topic, it has posed a challenge to students, going for the WAEC and JAMB exams. So let us define it. Trigonometry can be defined as the study of triangles with relation to its sides and angles. Let me repeat that. Trigonometry can be defined as the study of triangles with relations to its sides and angles. Now, when we say triangle, we have different types of triangle. If you can go back to your main duration, we have the right angle triangle, we have the scalene triangle, we have the equilateral triangle, we also have the isosceles triangle. But for the knowledge of trigonometry, we are going to look at right angle triangle because of its specialty. Go with me on the board. So this is the right angle triangle we will be dealing with. Alright? If you go back to your GSS classes, you have heard of an acronym called SOHCAHTOA. Okay? SOHCAHTOA simply means C. S standing for sine, the O for the opposites, the H for hypotenuse, C for cosine, A for adjacent, H for hypotenuse, T for tan, O for opposites, A for adjacent. Let us write that just as a reminder. Good. Alright, so from what we have on the board, this that reminded you of what you did in your GSS base. So please take note of this, don't forget, we're still using the same acronym. Now, we have three trigonometric ratios: the sine, the cosine, and the tangent. Okay? Now, let us see if we can get the fractions out. From the board, don't forget, I place an angle, I put my theta here, and take note, anywhere the angle faces, that is what we call the opposites. And in the right angle triangle, the longest side always remains the hypotenuse. Okay? Then the remaining parts of the triangle becomes the adjacent. So the angle faces the sine. Alright? So this side now becomes the opposite. Please mind you, I repeat, anywhere the angle faces becomes the opposite, please. So that's to say, I can equally remove this here and put an angle here, theta. But that means you don't tell me this is opposite anymore because the angle is facing here, so you could go this side. So this side becomes the opposite. Alright? So take note of that. Let me place it back to where it was. So this is the opposite now. Alright. So let us quickly derive something here and let's see. So I will take sine, so I can say sine theta is opposite. Can you say opposite? Opposite, that's C. That's hypotenuse A. Then can I take cos theta? Can I say cos theta? What is cos now? Is adjacent by hypotenuse. What is adjacent B? B hypotenuse A. So tangent, that's tan, theta is opposite, which is C, over adjacent, that's B. Okay? Please don't forget, this is just an abbreviation, so don't be confused. When I say SIN, I mean sine, SIN. So this cosine is tangent, this is an abbreviation. Alright? And do not forget, we also have inverse trig ratio, that's the inverse of the trigonometric ratios. When I say inverse, what do I mean? If I write A, I ask you what's the inverse of A, you will tell me 1 over A. Alright? So this, we have inverse. What's the inverse of sine? It's 1 over sine. Okay? And what is the real name given to it? Okay? Check this now. That is what we call cosecants. This is a full spelling. There's an abbreviation. What's the abbreviation? The abbreviation is seconds. Seconds. Or you can just say sec. Okay? Alright? Then we have the inverse of cos, that's not the cos. Alright? So what is the abbreviation is seconds. Seconds. You can easily call it just sorry, this is a cosec as a brief abbreviation, cosec. The secant now becomes just sec. So when you see these things, please don't be confused. When I say 1 over sine, I say secant, cosecant. Then in the abbreviation, you just say cosec. Then 1 over cos is called secant. In the abbreviation, you just say sec. Then when you come to this, the inverse of tan is 1 over tan, alright? And then, what is the full spelling? Is cotangent. Cotangent, that's the full spelling. And if you want to shorten it, you just say cos. Cos. Please, if you keep this, it will help you. Instead of you writing, boring yourself, writing cosecant, just say cosec. Say secant, just say sec. Say cotangent, just say cos. This is abbreviation. So let us get it right. So if I want to give you the values here now, just for me to swap it. So what is the cosec theta? Cosec theta is now A over C. I'll just swap it here. A over C. Now what is your secant? Secant becomes what? A over B. And of course, what is your cotangent or your cos becomes B over C. So that tells you that in trigonometry we also have inverse. Okay? Now I will give you another introduction, which are called the special trigonometric ratios. The special trigonometric ratios. Or I can call them special angles. Special angles trigonometric ratios. There are special angles. We have 3 of them. That's where we're going. Special angles trigonometric ratio. Special angles trigonometric ratios. What are those special angles? Number 1. Look at 45 degrees, 30 degrees, and 60 degrees. These are the 3 special angles trigonometric ratios. Alright? Let me give a summary. For 45 degrees, this is the right angle triangle. On the hypotenuse, you have the square root of 2. On the adjacent, you have 1. Here you have 1. This is actually 45 degrees. Here is 1. That means with this 45 degrees special angle, we can divide the 3 trig ratios. That means from here, I can say sine 45. I can get something of sine 45 degrees. Sine 45 degrees what? Don't forget that sine is opposite over what? Hypotenuse. Where is the opposite? Anywhere the angle faces. So opposite 45 degrees facing this side, this is the opposite. Hypotenuse is what? This. So that means sine 45 is 1 over root 2. Beautiful. Can I say cos 45? Of course you know that. What is cos? Adjacent over what? Hypotenuse. Right? So where is the adjacent? Adjacent is what? 1, hypotenuse is 2. That's 1 over root 2. Then of course you know, you don't need anyone to tell you this. Very easy. Why? Because tan 45 is opposite by adjacent. Opposite over adjacent. 1 over 1 is 1. That's why I have 1 here. Alright? Now, what's the summary? The summary is this. In the 45-degree special angles, there's something you can say. It means that sine 45 is equal to cos 45 is equal to 1 over root 2. I repeat, sine 45 is equal to cos 45 is equal to 1 over root 2. Then we will try to end with this and see if we can take 1 or 2 examples. Now, what is the special angles? Let us see if we can derive it. I will help you out here. In getting your 30 degrees and 60 degrees, you can get it from your isosceles triangle. Alright? Take an isosceles triangle like this, where all sides is 2 and all angles 60 degrees. All angles 60 degrees. All angles 60 degrees. Let's assume that we want to divide the isosceles triangle, sorry, the equilateral triangle, please. The equilateral triangle, we want to divide it into 2. Please, I've mentioned the isosceles, please correction. Equilateral triangles. Okay. So let us say we want to divide the equilateral triangle into 2. What will happen is this. When you divide into 2, this side is 30 degrees, this side is 30 degrees, right? So you divide. What you're going to have is this. You have a splitted angle, right? So this side is 2, don't forget. Then this side becomes what? 30 degrees, that's half of it. I'm taking this side, please. Now here's angle 90. Here's 60 degrees. Of course, here will be 1. Why is it 1? Because from here to this side is 2. So when you divide, here will be 1, here will be 1. So we are taking one part. So here is 1. So this is what we're going to use. Alright, it's not complete. Check. Is it complete? It's not complete. Okay? It's not complete. Why? Because we don't know this side. Okay, well, let's help ourselves. Let's help ourselves. Let's use the Pythagoras theorem to get this side. Don't forget that this is hypotenuse, this is adjacent, then let us take here as B. So, Pythagoras theorem. We said the hypotenuse side, which is 2 squared, yeah, is equal to the opposite side, that's B squared plus the adjacent side, 1 squared. So 2 squared is 4, then B squared, 1 squared is 1. If you collect like terms, your plus 1 on the left hand side will come to the side. That's 4 minus 1 is equal to B squared. But when plus 1 moves and crosses the equality sign, it changes to minus 1. So 4 minus 1, you will get 3. It's equal to B squared. Then taking the square root of both sides, your B becomes the square root of 3. That's root 3. Meaning that this side is root 3. So with this now we can solve the questions. So summary. What's the summary? Look at it. Can you tell me from this diagram over there, this diagram. From this diagram, tell me what is sine. Sine, let us take the 30 degree first of all. Sine 30 degrees. Simple. Sine 30 degrees. You follow the angle. Where is 30 degrees here? Where is it facing? It's facing the side. So every time you see where the angle faces, that's the opposite. Of course, here's the hypotenuse. So that means sine is 1 over 2. What is cos 30 degrees? Alright, the same thing. Opposite. Cos is what? Adjacent over hypotenuse. Where's adjacent now? This is opposite now. So here become the adjacent. So adjacent is what? Root 3 over what? Hypotenuse 2. So what is tan 30 degrees? Tan 30 degrees, tan is what? Opposite over adjacent. Yes, opposite, yes, adjacent. Of course, so tan is 1 over root 3. Summary. Can I take 60 now? What is sine 60? Sine 60. Don't get confused now. This is your angle 60 degrees. 60 degrees is facing this side. Okay? So here's the opposite. Here's the adjacent. Delta 2 there remains the hypotenuse. Alright, so I'll get us root 3. So opposite over hypotenuse, root 3 over 2. Then what is the cos 60 degrees? Remain now. So 60 facing here, opposite, adjacent, hypotenuse. So what is cos? Cos is adjacent of hypotenuse. So here's my adjacent, here's my hypotenuse. So cos 60 degrees is 1 over 2. And of course, what's the tan 60 degrees? Tan 60 is what? Tan is opposite of adjacent. Where's opposite? Root 3. Adjacent is what? 1. So I'm root 3 over 1, same thing as root 3. Summary. Now, summary of this whole thing. Check very well, you see something here. What's the sine 30? 1 over 2. What's your cos 60? 1 over 2. Can I see something here? Can I say that sine 30 degrees is equal to cos 60 degrees, right? Equal to 1 over 2. Alright? Then can I say that, look at check something please. You will see that cos 30 is root 3 over 2 and sine 60 is root 3 over 2. So can I say that cos 30 is equal to sine 60 and both are equal to root 3 over 2. Okay, so beautiful. So this summary code is very important. We are going to use it to calculate as we move on. Okay, but can you just permit me to just take just one question? I know I'm here for introduction, but just one question will help. And then we'll see how to go about it. Alright, now just one question please. Alright, so we say this, can I use this side? If you have a simple, very simple question, mind you, we've not gone far. This is just introduction to trigonometry. Find the value of the unknown side. Find the value of the unknown side. The question now. Find the value of the unknown side. Find the value of the unknown side. Alright, we have 4, we have 45 degrees. Okay, so this is a simple question, very simple question. So you are looking for the value. This is not the question. The question is, what side am I giving? Where is the angle located? That's the question. The angle located here, 45 degrees. And you know everything about 45 degrees. Alright, so if 45 is facing this side, then you call the side opposite. So I'm saying x as opposite. Then the longest side hypotenuse, right? So I'm saying 4 as hypotenuse. Okay, now from the so car, from car, and from toi, which of these three ratios is satisfied? That's the question. Which of them is satisfied? Of course, there is opposite, there's O, and there's H. Which of them is satisfied? You don't need anyone to tell you that. Oh, that means sine is satisfied, right? Because you have OH, so work with sine 45 degrees. So we go. Sine 45 degrees is opposite over what? Hypotenuse. That's x over what? 4. Beautiful. By trig ratios, what is sine 45 degrees? I don't think I've wiped it. Have I wiped it? Okay, I've wiped it. I will help you. So this is the right angle triangle. If you forget, you can quickly draw. And don't forget that yes, root 2, yes 1, yes 1, yes 45 degrees. Forget that. So with this knowledge, you are good to go. So sine 45 degrees, go with me now. Opposite cos over hypotenuse 1 over root 2. So you go here. So sine 45 is already 1 over root 2. 1 over root 2 is equal to x over 4. So you don't have anybody to tell you what to do. You cross multiply. So if you cross multiply, what do you have? So you go this way. Cross multiply. 4 times 1, x times. So this will give you what? X root 2 is equal to 4 times 1 is 4. You go this way. 4 times 1 is 4. X times x root 2. You're looking for x, right? You divide both sides by root 2. Clear it off and get x. So I divide here by root 2. That's x root 2 by root 2 on the left hand side. And we'll have 4 root root 2, 4 over root 2. This root 2 cancels root 2. You have x left. I don't know whether you know about SOLD. But if you know about SOLD, you need to rationalize. How to rationalize? Because in SOLD, you don't leave a root at the denominator. You don't. So you rationalize. What is rationalization? Simple. This is root 2. And not only that, it's a basic SOLD. So I will take the root 2 to multiply up and down. So I will say 4 over root 2, I bring it down. And I'll take root 2, go up, root 2, come down. That same root 2 at the denominator, I just multiply up and down of that fraction. So here we go. So x is equal to 4 times root 2, you will get 4 root 2 because they are different. This is a SOLD and this is a number. Now, root 2 times root 2. In SOLD, the principle says that when a like SOLD multiply, the answer becomes a number in the root. Okay? So if I say root x times root x, it's simple as ABCD. Because among this root and this root, they're the same. But so the answer becomes the number or the letter inside that root. That's x. So what's the answer now? Root 2 times root 2. What's the answer? 2. So you go. This time just give it 2. So 2 divided 4. Don't forget that if you have something like this, you cannot cancel out. There's a plus sign here, so you can't cancel out like this. It's not possible. But because there's no sign between, there's a multiplication, you can cancel. 2 here 1, 2 here 2. So you're going to get 2 root 2. You put centimeter just to add something as a unit. So with this, I think I have given you the introduction you need. We are going to meet in our next class where we're going to expose trigonometry better than this. Thank you for viewing, thank you for watching.